Today we're going to learn how to divide using a square root. In mathematics, we call that rationalizing the denominator. In math, you were taught so far that you cannot divide by zero. Well, a fraction is just a big division problem. Now, the next rule or property that I'm going to present is the idea that you can't have a square root in the denominator. Now, sometimes this is simple and sometimes this is a little bit more tricky. So I've come up with a series of questions to go over. The first one states 18 over the square root of 9. Now this one we really don't have to do much work to do. All we have to do is to consider the idea that it's two separate problems. 18 is just 18, whereas the square root of 9 is 3. That's not too bad. 18 divided by 3 is 6. So sometimes the square root will cancel out completely. Now, just like with multiplication, division can be separated into two separate problems. The square root of 7/4 is actually like saying the square root of 7 divided by the square root of 4. Now, the square root of 7 you can't simplify because there's no perfect square that divides into 7 evenly. So that's going to say the square root of 7. But the square root of 4 is just plain old 2. Now, the only rules about square roots states that you cannot have it in the denominator. There is no rule that says you can have it in the you cannot have it in the numerator. So you're done with this problem. But what do I do if I simplify something and I still have a square root in the bottom? That's where the two rules above come into play. It says multiply the numerator and the denominator by the radical in the denominator and then simplify. So the radical or the square root in the denominator is the square root of 5. So what I do is I multiply the top by the square root of 5 and the bottom by the square root of 5. Square root of 5 divided by square root of 5 is just 1. So really all we're doing is multiplying by 1. Now when we do this, we multiply our numerator times our numerator, 3 times the square root of 5. Remember, 3 is the whole number. It's just going to become 3 square roots of 5. Now our denominator is going to be the square root of 5 times the square root of 5, which is the square root of 25. Now the square root of 25 is plain old 5. So we have 3 square roots of 5 over 5. Now, the top 5 cannot be canceled with the bottom 5 because square root of 5 is very different than a whole number 5. But if you think of these just like with normal fractions, the whole number on the top is 3, the whole number on the bottom is 5, and I would ask myself, does 3 over 5 simplify? Which it does not. So the answer to my problem is 3 square roots of 5 over 5. Let's try a few trickier ones. Let's do 5 divided by the square root of 6. Step 1 says multiply the top and bottom by the radical in the denominator. So we're going to multiply top and bottom by the square root of 6. Once again, this becomes 5 square roots on 6 on top. But on the bottom we get square root of 36. So I have 5. Square root of 6 has no perfect squares, so it's just square root of 6, all divided by the square root of 36, which is 6. My whole numbers are 5 and 6, and 5 over 6 will not reduce. Let's try one that does reduce. A lot of times in mathematics, it's actually easier to simplify at the beginning versus the end. So on this one, I'm going to actually simplify before I start. I know the square root of 8 is the square root of 4 times the square root of 2. So really I have 4 over square root of 4 is 2, so 2 square roots of 2. All we're doing is simplifying. Now my whole number on top is 4. My whole number on the bottom is 2. If they weren't reducible, we could just leave it and multiply by the square root of 2. But since they are, I'm going to go ahead and reduce that. That becomes 2 over the square root of 2. Now, I still haven't gotten the square root of 2 out of the denominator. So I multiply the top and bottom by the square root of 2. thus leaving me 2 square roots of 2 over the square root of 4, which is just 2. The 2's cancel, and I'm left with the square root of 2. Now, say I didn't know that. Say I just used the same process we were doing before. 4 divided by the square root of 8. And I multiply the top and bottom by the square root of 8. Well, I get 4 square roots of 8 over the square root of 64, which is 8. Okay? My whole numbers are 4 and 8, so they reduce to 1 and 2. But the square root of 8 can actually be simplified. We said the square root of 8 is the same thing as saying the square root of 4 times the square root of 2. And the square root of 8 just became 2 square roots of 2. So this is really just 2 square roots of 2 over 2, which cancel, yielding square root of 2 as an answer again. So it doesn't matter which way you do it, whether you simplify before or after, you still get the exact same answer. Let's try a couple more and this should finish it off. Okay, using that basic idea from before, I can't have a square root in the denominator, but in order to take a square root of a fraction, I take a square root of the top and the square root of the bottom. Well, the square root of 4 is 2. Square root of 7 I can't do. I would try to simplify, but the square root of 7 doesn't simplify, so I leave it. I multiply the top and the bottom, or the numerator and the denominator, by the square root of 7, thus rationalizing it. 2 times the square root of 7 is just 2 square roots of 7 over square root of 7 times the square root of 7 is square root of 49, which is just 7. And remember that the square root of 7 inside does not cancel with the square and the 7 on the outside because they are not equivalent in value. Now 7 is prime, so it has no perfect squares that go into it, so that is my reduced answer. One last one and we'll call it quits. Square root of 12 fifths. Well, we break it up to the square root of 12 over the square root of 5. Okay? Well, I might go ahead and simplify the top. I know that 12 is the square root of 4 times the square root of 3. So really this is 2 square roots of 3 over the square root of 5, which doesn't help me much. I still have a square root in the denominator, so I still need to multiply by it. So I have square root of 5 and square root of 5. Top, my whole number is 2, and I have an imaginary 1 there, so 2 times 1 is 2. We multiply the whole number coefficients. Then, just like with multiplication, we multiply the numbers inside our radical. 3 times 5 is 15 over square root of 5 times the square root of 5 is the square root of 25, which is just plain old 5. My whole numbers are 2 and 5, which don't reduce. 15 and 5 cannot reduce because the square root of 15 is not equivalent to 5. I look and I see, is 15 have any perfect squares to divide into it? No. So that's the answer to my problem. Now, just like with before, if you don't like that method for simplifying before you start, break it up and go ahead and multiply the top and bottom by the square root of 5. If you get that, you get the square root of 60 over 5, and then you would realize that that is 4 times 15, which would still give you 2 square roots of 15 over 5. I hope this video has been helpful. You have 9 problems which can be found online in Google Classroom for you to complete. You're more than welcome to look back at these at any time and get to going on rationalizing denominators.